today's demonstration, we're going to create a WLAN that is enabled with dynamic pre-shared key using the RUCKUS WAN Gateway. Dynamic pre-shared keys increase WLAN security by providing an individualized pre-shared key to each user or room depending on how you have the configuration deployed. If you watched the microsegmentation demonstration, we had layer 2 VLANs associated to layer 3 networks. So we had some additional security there as well because each user coming in would be placed into their own network, and the firewall policy didn't allow subnets to talk to each other. So each user had their own gateway. So DPSK kind of increases the amount of security because if one user's pre-shared key is compromised, it doesn't impact any of the other users of the WLAN. This will allow us to build on top of the microsegmentation use case and add DPSK on top of it. Speaking of the use cases, we are going to kind of review 3 of them, but we're only going to walk through the configuration of one of them. The first use case is where you have DPSK connected clients that are associating to the same VLANs. As you can see here, we've got VLANs 100, 150, and 200. Each of those VLANs are connected to a policy, which is connected to an account group, and each of those account groups have their own individual accounts in DPSK. This is something that you would actually create in advance. Maybe you've got an enterprise network that you're wanting to get created, and you have an engineering group, a sales group, and an HR group, and maybe even more than that. But as you scale those VLANs out and create more of them, you have to create more policies, more account groups, and more accounts. So out of the use cases that we're going to talk about, this is probably the one with the most configuration. In the next use case, we do have those users connecting to the WLAN using their dynamic pre-shared key, but they're associating to a VLAN pool. So each user connecting into the WLAN will be associated to a different VLAN from the pool, and it's going to get its own dedicated subnet. This is basically the microsegmentation demonstration, but we're adding DPSK on top of it. The last use case, and the one that we're actually going to demonstrate in this video, is much like the previous use case, but we're adding in a property management server. So what we're doing is instead of manually defining these accounts, we're going to tie into a property management server and have it define these DPSKs for us. So again, the users are going to connect in, they're going to be associated to a layer 2 VLAN that has its own network, but we're going to get that information for the DPSK from the property management server. Before we get started with the configuration, just a quick rundown on how this lab is built out. We do have a virtual RUCKUS WAN Gateway appliance with 2 interfaces, VMX0 connected to the internet, VMX1 connected to our lab ICX. Also off of our lab ICX, we have our virtual smart zone, as well as a RUCKUS AP that is going to broadcast the DPSK WLAN for our clients to connect. Kicking off the configuration, we're going to begin by creating the VLAN pool that we're going to use for our DPSK network. Let's go over to Network, LAN, and under VLAN interfaces, click Create New. We need to create a name for the VLAN interface, and I'm going to enter in DPSK VLAN pool. We need to associate it to the physical interface that is connected down to the ICX, which is VMX1. We then need to set the starting VLAN ID, and I'm going to go ahead and choose 200 here. Again, we are doing per subnet auto increment at a ratio of 1. So we're going to create VLAN 200, 201, all the way up through as many subnets as we actually tie to this particular pool. But again, if we wanted to choose none, it would create just that singular VLAN, but we want to actually create several, so we're going to choose per subnet. Once all that's selected, go ahead and choose Create. The next piece that I need to create are the network addresses that I want to attach to that DPSK VLAN pool. So under network addresses, I'm going to go ahead and choose Create New. I'm going to name this DPSK network addresses, and then I'm going to set the VLAN to the DPSK VLAN pool. I need to define the starting address in which to create these networks. So I'm going to actually set this to 200.0.0.1/30. Again, the /30 is going to give us 2 usable host addresses per network. I'm then going to set my auto increment. I'm going to actually set this to 82 because that's how many users that I could potentially connect in based on how many rooms or users I've got in my PMS system. So I'm going to go ahead and create all of those now. And again, it's going to be a span of 1. So it's going to be right one after the other. It's not going to skip any ranges. And then I want to make sure that each of these networks has a DHCP pool. So I'm going to go ahead and check the automatically configure a DHCP pool box. And once all that's done, I'm going to choose create. With that done, we can see the network addresses now shows our DPSK range starting at 200.0.0.1 through 200.0.1.69. And we can see our VLAN interfaces start at 200 and end at 281. The next thing that we need to do is check our NAT configuration, which we can do under Network NAT. Automatically created when we defined the DPSK network addresses was a disable NAT rule. So what we actually need to do is we need to edit this and we need to go ahead and rename it. I'm going to just change it to DPSK network addresses, and I'm going to go ahead and select our uplink so we can actually do NAT on this network. So our subnet's already chosen here, and with all that changed, we should be able to hit update, and now we have a NAT rule for that network range. An interesting note here regarding NAT, if you are running out of a private RFC 1918 address space, so 10.0.0.0 or 172.16.0.0 or 192.168.0.0, RWG is going to automatically enable NAT for those subnets, but it's not even going to show that there's a NAT entry in this scaffold. It's just going to do it behind the scenes. So if you're utilizing any of that address space, you might not need to do that. But since we started at that 200.0.0.1 range, we had to go ahead and modify the automatic created NAT deny entry. Next, we need to create a switch port profile to associate the DPSK VLAN pool to our switch ports. We can do this under Network, Wired. Underneath the switch port profile scaffold, we're going to choose Create New. We're going to name this DPSK Switch Profile. We're going to select the ports that we want to associate. So that's going to be port 2 towards our AP and port 12 for our uplink. Under tagged VLANs, we need to go ahead and choose our VLAN, DPSK VLAN pool group that we created. And then we can go ahead and choose Create. If we jump into the console of our ICX and run Show VLAN Brief, we can now see that we've got VLANs 1, and then we have 200 to 281, as well as the other 999 and 4094 VLANs. But the 200 to 281 is the ones that we've just configured with this switch port profile. And if we run a Show VLAN, we can see that these are tagged in both port 2 and 12. Now we're going to create a new policy to attach to this DPSK VLAN pool. We're going to go ahead and click on Policies, and we can see all of the created policies that I've defined, as well as the default policy and some of the matches for that, for the web server, DDoS, protection, block subnets, as well as the bandwidth queue. But scrolling down under policies, you can see the defined policies here. I'm going to go ahead and create a new one by clicking Create New. I'm going to call this DPSK policy, and I am going to select two things here. I'm going to go ahead and set the bandwidth queue to 100%, meaning that we will have all available bandwidth for this policy. And then I am going to go ahead and set my subnets filter to block subnets. So all of the users that are connecting in to these different VLANs using these DPSKs are not going to be able to communicate with each other because they are going to be blocked in that communication. With that selected, I'm going to scroll down and choose Create. Now that I've got a policy created here, I'm going to go ahead and create an account group and attach it to that policy. I'm going to go under Identities, Groups, and under Account Groups, I'm going to go ahead and click Create New. I'm going to call it the DPSK group. I'm going to disable the enhanced PSK security because if I don't check that, I wouldn't be able to create similar PSKs. And in this particular lab example, I might do that. So in this case, I'm going to go ahead and allow it to do that. And then I'm going to choose what PSK character set and length I should be utilizing for these PSKs. And we have hexadecimal, A through F, 0 through 9 by default, as well as 16. I'm okay with both of those, so I'm going to go ahead and leave that. But underneath the policy, I am going to go ahead and choose that new policy that we just created, DPSK policy, and then I'm going to go ahead and choose Create. So if I scroll back up and click on policies, we can now see that my DPSK policy has a DPSK group tied to it, and we can see which attributes are kind of connected to this policy. Again, we've got the bandwidth queue as well as the block subnets. Now we need to create a radius realm that starts to tie all of these things into a radius policy. We can do this under Services, Radius, and underneath the Radius Server Realm scaffold, we need to click Create New. We're going to call this DPSK Realm, and then we need to start filling out some information here. We're going to leave the rank as 0. We're going to accept the default policy or attribute pattern logic, and then we're going to select the DPSK policy. Under the attribute pattern, we're going to choose 0 or, and then we're going to set the BSS ID, and then we're going to set the pattern. So again, this is the name of the WLAN that the user is going to be connecting to. So Radius knows to use this realm when users connect to this WLAN. And I'm just going to call it DPSK WLAN. Underneath Dynamic VLANs, I'm going to go ahead and choose per account, which it already is selected. I'm going to make sure that our DPSK VLAN pool is checked. We also want to make sure reuse is checked, so we can reuse any of those VLAN tag assignments if it's needed. And then underneath the VLAN call station ID, we want to make sure that unlimited is selected here. Underneath infrastructure devices, I want to make sure that I am selecting my smart zone. And then underneath proxy servers, I'm going to make sure that my PMS server, my property management server, is selected here. Now, I haven't shown the creation of this particular PMS test server that I have, but we will get to that. We just need to make sure that we've defined it here. Underneath proxy options, I need to make sure the option to create accounts for new proxied authentications is checked. This is going to make it so that these users generated from this PMS database are going to have accounts created. Underneath behavior, we need to make sure we have tunnel type VLAN, tunnel medium type IEEE 802. Then we need to make sure tunnel private group ID VLAN tag assignment is selected, but we need to unselect the account pre-shared key and make sure that we select Ruckus DPSK. With all of that now configured, we're ready to click Create. We now need to create the WLAN that we're going to use for this DPSK network. Let's navigate over to Network, Wireless, and from under the WLAN scaffold, we're going to go ahead and click Create New. We're going to name this DPSK WLAN, and we are going to select the access point zone. Site A is where the AP lives, and then our controller is Smart Zone 51. We do want to make sure we attach that to the default AP profile, so I'm selecting the default for Site A, and then we're going to set the SSID to match DPSK WLAN. Again, this is how we set the radius policy as well, so these need to match for that to be active. And then I'm going to set my encryption type to WPA2, and I'm going to set the authentication to multiple PSK. I'm then going to change the VLANs. By default, it looks like both of the pools that we created were selected. The DPSK VLAN pool is the only one that we want for this. And with that defined, I'm going to go ahead and choose Create. Now that we have the WLAN created, we're almost ready to test the DPSK connection, but we need to generate some actual DPSKs for clients to be able to utilize. So in the first two use cases where we talked about kind of enterprise type of deployments, those might be defined manually, and they can be done by creating accounts within RWG, but we said for this particular use case, we were going to tie into a property management server so that those accounts could be generated for us. If I scroll up to billing and go to gateways, we can see the PMS server that I've created here. This is one that's running internally, but if you had a property management system, if you were a hotel or a resort, you could click Create New, and you could select the type of PMS system to integrate here and get the connections going for that, so that when you were able to import it, it would bring in your guests and rooms, much like it's done here for my internal test. So you can see that I've got rooms with guests assigned, and I've got guest details for all the guests in these rooms. But I don't necessarily have DPSKs for these yet, because I actually need to go ahead and create some custom data sets that tell me how I'm going to actually create DPSKs based on the information that's in these databases. To do that, I need to go over to System, and I got to go to Portals. And the first thing that I need to do is create a new data set. So under Custom Data Set, I'm clicking Create New. And I'm just going to call it PMS DPSKs. And I need to put in PMS in uppercase in the note field and click Create. So that's kind of the heading. So we know that we want to do some DPSKs off of PMS, but what about the data in there do we want to key off of? That's where the custom data key information comes in. And we're going to create kind of two different things and then take a look at what it generates. So we're going to click on Create New under Custom Data Keys. And we need to select, or it's already selected, our data set. We're going to set a name of PMS_guest. So this means that we do want to utilize the guest name for that, and we're going to specify that as name. So we're saying, hey, look at the PMS guest field and grab the name. We're going to add that, so that's going to be part of our custom data key. And then I'm going to do another one as well. So name is not just enough. I think I want to also do room. So I'm going to call it PMS_room, and we're going to grab a string of room. All right, and now one thing that is a little different about this setup is that I actually need to log in via SSH to the console of my RWG and take a look at that database so I can see the DPSKs. So let me go ahead and bring that up. So I'm going to jump into the console here. And from the console, I can run pairwise master key.count. I have 0. That's because after I created these custom key sets, I forgot to go over to billing gateways and actually restart the PMS test interface. So I need to click restart interface here and choose OK and refresh and go back over here and run this count again. All right, so I have 328 DPSKs that it created based off of the information I told it to pull. But if I wanted to actually see what they are, I'm going to change this command to pairwise master key.all. And I can see the first couple that it's created here. They're all related to Spock in room 127. And if I look behind me at the RWG interface, I can see that I do in fact have a Spock in room 127. So the way that we've told this to work is to grab the name and the room number and mash those together. So we've got Spock 127 with a capital S, no space, and then we have Spock with a space 127. Then we have 127 Spock uppercase and 127 space Spock. So we can go down through this and look at all of the different iterations. It looks like there's 4 different iterations per user account with variation on the spacing, but no variation currently on the capitalization of that name. So what I actually want to do is I want to get out of this and I want to take a look at adding another data set. So I'm going to go back over to System, Portals, and I'm going to create another data set. And I'm going to call this PMS lowercase. I'm going to put PMS in the note again. And I'm going to create a couple more custom data keys for that. So I'm going to make sure I select my lowercase data set. And then in the note, I'm going to put in LC. That's key for lowercase. But what am I going to make lowercase? Well, the numbers aren't actually in a case. So they're just numbers. I actually want to do the guest information. So I'm going to type in PMS guest here. And I'm going to have that name string again. So what I'm saying here is that, hey, go ahead and put that name in a lowercase for me. I'm going to go ahead and click create, but I still want room numbers attached to this. So I'm going to go ahead and add another custom data set, and I'm going to reattach our PMS room information. So PMS_room and a string of room, and click create. So what this should now give me is not only those uppercase lettered names associated with rooms, but also a variant in lowercase. So basically, any way the user types this, we just say, hey, you're able to get on the WLAN, just type in your last name and the room number. It doesn't matter how they type it. lowercase, uppercase, space, no space, room first, room last, it's going to work. So I need to go back over to billing, gateways. I need to restart this interface just so it can generate that stuff again. Jumping back over to my console, I'm going to rerun the pairwise master key count. You can see now we've got 656. Okay, cool. So that's definitely more than we had before. And let's take a look at all. And we can see we've got 127 Spock lowercase, 127 Spock uppercase, Spock with a capital S 127, Spock with a lowercase s 127. And then we can do the same thing with the spaces again. So now each of these room and guest combos kind of have 8 different ways they could type it in, which is going to make it easy for them. And we didn't really have to do much to generate that, right? We set up these custom data values, and then we're tied into our PMS system. So as long as things are being fed to the PMS system, this stuff's going to be automatically generated. Let me just copy Spock 127 down, and we'll try to connect in to our WLAN using that, and maybe we'll grab another guy at the same time. Okay, so let's imagine we're Spock and we're sitting in room 127 and we're needing to connect to the Wi-Fi. We can see our DPSK WLAN here, and we're going to choose connect, and it's asking for a key, and we're Spock. So I'm going to type in Spock 127, all lowercase. I can look at that, and I'm going to choose next, and I'm going to go ahead and say yes. Maybe I've got a Chromecast that I also want to get working, and I want to be able to cast to it. So let's see how we connect up. And we did get connected in there. Let's take a look at our addressing. And you can see I was put in 200.0.0.14, and my adapter is 6947. So we can take a look at that when we jump back over into the RWG. But while I'm sitting here, I'm going to also from a phone connect in, and I'm going to try to get the recording on the phone to work, but I'm going to connect in. So we have Mr. Kirk in room 1180. Let's try to connect in as Mr. Kirk on that room and see what we get. So here we see the DPSK WLAN for Mr. Kirk, and if we click on it, we can enter in, let's say 1180 Kirk. We're doing it a little backwards, but let's connect in 1180 Kirk, and we are connected in. Let's take a look at this connection and see what IP address we've got. We're at 200.0.0.6, and our MAC address is E704. So let's jump back over to RWG and take a look at these clients and see what information we can find out about them. Back in the RWG instance, I'm under Instruments, MAC DHCP DNS, and I've sorted by IP just so I could see the 200 addresses here first. And we can see both of our MAC addresses here. We can see our laptop and our phone, and we can see the associated VLAN for each of those devices. So again, VLAN 203 and 201 for each of them based off of that DPSK VLAN pool. So we have this dynamically created key that we were able to generate based on the property management system data, and we were able to feed that into a DPSK WLAN that utilized radius attributes to place those users in dynamic VLANs attached with layer 3 networks of their own. So not only are these guys more secure on the WLAN, but they also are secure from a layer 2 and 3 perspective because they cannot talk to each other. So that's all we wanted to show you for this demo. I know it was a little bit of a longer one, but we wanted to get through the entire process in one shot. So hopefully that helps you guys, and we look forward to seeing you in the next one.